Hi, I'm Jianling Pan, and this is my colleague Wei Yuanwu. We are PhD students from San Francisco University, advised by Dr. Jiannan Wang. Today, we will present DataPrep.EDA. This is a joint work with Cornell University and the Chinese University of Hong Kong. In 2014, New York Times reported that data scientists spend 50 to 80% of their time to prepare data. However, nowadays, their preparation is still the bottleneck. As the report of Anaconda in last year pointed out, we were disappointed, if not surprised, to see that data wrangling still takes the lion's share of time in a typical data professional's day. So why is data preparation so hard? Let me use cooking as a comparison. How much time do you spend on food preparation, and how much time do you spend on the actual cooking? I believe most people will spend most of their time on preparing food. This is similar in data preparation. So why data preparation is hard? There exist three reasons. Firstly, data preparation is not a single problem, but contains many small problems. When you prepare food, you need to solve many small problems, such as buying groceries, washing food, and chop meat. This is similar in data preparation. For example, you may need to standardize date or deduplicate the address. Although they both belong to data preparation problem, the solutions may vary a lot. Secondly, humans have different levels of expertise. For cooking, you may be new to cooking or you may be a chef. Similarly, data scientists also have different backgrounds. Some of them are experienced in programming, but know little on the domain knowledge. Some of them are domain experts, but not familiar with the programming. The diversity of users make data preparation hard. Thirdly, data preparation requires many domain knowledges. In cooking, the food preparation for Chinese meal and French meal are different. This is similar in data preparation. The data preparation for financial data, social science data, healthcare data, and the economics data could be very different. These three reasons can explain why data preparation is a hard problem. To solve the data preparation problem, we need to get human involved. Then we need to think about how humans should interact with the system. Based on the interaction interface, existing solutions can be categorized into three directions: spreadsheet GUI, workflow GUI, and notebook GUI. We believe the three directions will coexist in the future, since they are targeted at different users. Spreadsheet GUI and workflow GUI are targeted at non-programmers, and notebook GUI is targeted at data scientists. Our work is focused on notebook GUI direction, because we believe that when more people will be trained as data scientists. In order to address the data preparation issue in Notebook, we started the DataPrep project 2 years ago, with the vision of building the easiest Python library to prepare data. Currently, DataPrep has three components: DataPrep.EDA, which simplifies exploratory data analysis; DataPrep.Connector, which simplifies web data collection; and DataPrep.Clean, which simplifies data cleaning. We also plan to develop DataPrep.Feature to simplify feature engineering, and DataPrep.Integrate to simplify data integration. DataPrep embraces the open source community. It has already been downloaded by more than 160,000 times, received over 750 stars, and attracted more than 30 contributors from different organizations. It's also received many good feedbacks from social medias. For example, in Reddit, we received comments like, "This will save me so much time. It has the potential to be a game changer." After introducing the whole DataPrep project, now let me present our work on DataPrep.eda module. So what is EDA? Whenever we get a dataset, the first step is to explore it, which is known as Exploratory Data Analysis, or EDA. EDA can help us understand the data and discover insights. Usually, the way of doing EDA is to create data visualizations or data summarizations such as statistics. For example, suppose we have a student table and we want to understand the age column. We may create some statistics such as min, max, and quantiles, or some variations. For example, a histogram to see the distribution, or a box plot to see whether there exist outliers. Currently, there are two solutions of doing EDA in Python. The first one is plotting-centric EDA. That is, using plotting tools such as Matplotlib or Seaborn to create validations or statistics. Using previous example, to understand the age column, data scientists will write code to generate statistics, write code to generate a histogram, and write code to generate the box plot. Since the APIs provided by plotting tools are at a very low level, plotting-centric approach is hard to use for both beginners and experts. For beginners, they will spend much time to figure out how to write plotting code, since they are not familiar with the plotting tools. For experts, they need to write lengthy and repetitive code whenever they analyze the new data. The second solution is profiling-centric EDA. That is, using data profiling tool such as panels profiling or AutoVis to generate a report. These tools will provide a very high-level API and allow you to create a report with one line of code. However, profiling-centric approach is slow. This is because it computes variations for the full data, including distribution for each column, correlation matrix, and the distribution of missing values. This is not necessary when you are only interested in part of the data, for example in some columns, or you are only interested in some variations such as missing values. Furthermore, since the report contains many configurations, it's also hard to customize. In summary, plotting-centric EDA system is hard to use since the API is at a very low level. And the profiling-centric EDA system is not interactive and not easy to customize since the API is at a very high level. How can we overcome their limitations and achieve all three design goals? Easy to use, has interactive speed, and easy to customize? Our answer is task-centric EDA. In the task-centric EDA system, each API is related to an EDA task. The task-centric EDA API design has two key ideas. Firstly, the API is declarative. That is, users only need to tell the system what they want instead of how to do it. For example, they could tell the system, "I want to see an overview of the data using plotdiff function," or "I want to understand the missing values using plotMissingDiff function." Then the system will automatically generate corresponding variations and statistics in order to finish the task. Secondly, the system supports both coarse-grained and fine-grained EDA tasks. Users can create a profiling report or see an overview, and they can also zoom into a single column by calling plotDFX or understand the relationship between two columns by calling plot df xy. With these ideas, we built DataPrep.eda, the first task-centric EDA system in Python. Next, my colleague Weiyuan will show a demo and finish the left presentation.
Hi, in this demo, I'm going to show you DataPrep.eda is not only easy to use, but also easy to customize. First, I'm going to load the dataset into a pandas data frame. Next, I'm going to use one line of code, which uses plot function to plot data frame. It will display a bunch of statistics and also some insights on the dataset, as well as the distributions of each column. You can also drill down a little bit by passing in a column name into the plot function. It will give you the statistics of that specific column, as well as more visualizations like bar chart and pie chart. You can also pass in a numeric column, which will give you statistics, but instead it will give you histograms and a KD plot and some numeric related plots. Finally, you can pass in two columns. It will give you the scatter plot, hexbin plot, and the box plot, which indicates a relationship between these two columns. You can also use plot missing to do missing analysis. This will give you some statistics and the missing bar chart, which indicates how many missing values for in each column, and also spectrum indicates where the missing value is located at in this column. You can also do plot correlation to do correlation analysis. Finally, we also provide a create report function so that once you call it, it will generate a report containing all the information you see above. Next, I'm going to show you how easy it is to customize the plot function. We'll take the plot df age as an example. First, I'm going to do is to allow that only stats and histogram can be shown in the result visualization, but no more. You can do this by specifying the display argument here. You can also customize the histogram bins by using the config parameter. The values inside the config parameter can be get from the question mark here. You can also see all the configurations in our documentation, this link. That's all for the demo. Thanks for listening. Next, I'm going to introduce how DataPrep.eda performs these tasks I demonstrated just now. The first thing we need to consider is that, given the code on the left-hand side, what plot are we going to put into the visualization on the right-hand side? In DataPrep.eda, we define a bunch of mapping rules for each function to decide what visualizations to show. I will cover this in the next slide. Another thing we need to consider is that, given a set of visualizations we'd like to generate, how are we going to compute the data that is required for these visualizations? One of the challenges is that because we need to compute data for multiple visualizations, doing it naively will make redundant computations and cannot make full use of the multiple cores in the CPU. In DataPrep.eda, we have a data processing pipeline to solve this issue. Let's talk about mapping rules first. As shown in the demo, the visualization displayed by the plotting function depends on the function name as well as the type of the column name. For example, for plot df column1 function, we will show a histogram and a KDE plot if the column is numeric. On the other hand, if the column is categorical, we show the bar chart and pie chart. The mapping rules are acquired from textbooks, blogs, and other open source projects. Since our library is open sourced on GitHub, we also get feedbacks from the community for adding new mapping rules. Once we decided a set of visualizations that we need to compute, the next step is actually compute it. There are 3 steps in our data processing pipeline. First, our config manager will parse the config parameter of the plot function because some of the configurations directly control the computation. One example is the computation of the histogram, where the number of bin is a parameter of the histogram computation. Next, we use the Dask computation framework to compute the data that is required for the visualization at once. Using Dask allows us to parallelize the computations as well as cut off redundant computations. Once the computation is done, we put the data which is ready for plotting into a container called intermediates. And then we use Boker to render the plot based on the data inside the intermediates. So that's how DataPrep.eda works under the hood. The compute module is one of the key components of our library. We consider the multiple choices date back to the beginning of this project. For example, Spark, Modding, and Dask. Finally, we chose Dask because first, it is lightweighted and fast in single-node environment. Second, it can scale to distributed environment. And third, it can optimize the computation required for multiple visualizations using lazy computation. Based on the property of Dask, we did optimizations like making computations shared between visualizations, as well as making all the computations lazy. We also found that Dask can introduce overheads on tiny data. For example, it is not worth it to use Dask to do computations inside the render module because the data there is usually small. In this case, we use pandas to do computation. Given these optimizations, our library can achieve interactive speed on different EDA tasks. In this experiment, we used 15 commonly used public datasets and enumerated all the possible column combinations to call the plot function. For plot df with single column, 97% of the tasks can be finished within 2 seconds, and 99.6% of the tasks can be finished within 5 seconds. For a plot df with 2 columns, all the tasks can be finished within 2 seconds. We also compared the efficiency of our library with pandas profiling on the report creating function. Again, our library is up to 20 times faster than pandas profiling. Besides the performance, we did user study to do end-to-end testing as well. We recruited 29 participants, contains undergrads and postgraduate students. We designed 5 questions for 2 datasets each. Each participant can spend at most 5 minutes to answer these questions. We got a very positive result. On average, the participants complete 2.05 times more tasks and answered 2.2 times more correct answers comparing to pandas profiling. Some feedback include fast and responsive, more control, and easy to understand. DataPrep.eda itself is not alone. There are existing EDA tools in Python and R ecosystem. For example, Lux from UCB. There are also company products like Tableau, Excel, and SPSS that can help you do EDA. Finally, there's a category called data profiling, which contains tools like Metanome, pandas profiling, SweetWiz, which are also related to EDA. However, DataPrep.eda is the first task-centric EDA tool in this area. In summary, DataPrep.eda is the first task-centric EDA system in Python, and it achieves 3 design goals: easy to use, interactive speed, and easy to customize. If you are interested, it can be easily installed using pip. Thanks for your time listening.